Hi everybody, this is Mr. Roche. We are working with Tinkercad circuits, and what I wanted to do for homework is just make sure that you guys are making Tinkercad things okay. And we're going to do a little bit of experimenting we're using batteries and LEDs, and we're looking at kind of circuits that we can make with them. So let's launch Tinkercad circuits, and let me just go over a little bit more about Tinkercad circuits. Okay, so what happens is when you get to Tinkercad circuits, it makes you a project, and you can name this like we'll use it like LED circuits. It'll be like something like that. So then this becomes something that you can see in your. If you go back to here, you can see this listed as a project. Otherwise, it comes up with these sort of random names, and you'd have to remember what they were. What we're going to do was we're going to start with the breadboard. I'm going to pull out the 9 volt, which is a lot more than what we need. And what we learned also is that you can rotate a device by doing that. So as long as it's highlighted, right? Okay, now it's going to make wires for me. But if you want to delete a device, you hit the delete button. But you can highlight each of the devices and then do things with it, right? I'm using my scrolling ability to go back and forth and give myself a little bit of space between these two components. And then what I was doing was I was going to make a wire connection between these two. As we looked at a battery, there's a positive end and a negative end. And in that way, the negative electrons go over to the positive side. And the voltage is the pressure at which the electrons can move. Okay, so like a higher volt, like if it's 12 volts, there's going to be more pressure, and if there's like 1.5 volts, there's going to be kind of less pressure. Okay, so each one of these like has different voltage pressures. Okay, so what I'm going to do is just make this connection here. Okay, so it goes to that, and this goes to here. Just for nice, you could put them both up on here, be fine. And then generally, typically what you want to do is you want to color the wires to be the color, that you're thinking of, so that they're not all the same color, so that it's easy to read what's going on in the diagram. Typically, the electrons come from the black side here, and then they move around and they go back to the red side. Okay. And on Tinkercad circuits, if you just double click here, it'll make a kind of a node for you. So you can go like this, and you can neaten things up. And when you're doing electrical work, neatness kind of counts. So you want to be, kind of as organized as you can. And Tinkercad circuits is good for that. So there you go. So that's now we have a kind of a connection. Okay. And then what would happen right now, like for example, if I went like this, and I'm going to go like this for a second. Okay, so now I've got this like weird connection here, and I'm going to actually short circuit the battery. So I don't know, let's see what happens if I do this, because what's going to happen is it's going to like blow up, I think. Let me see. Yeah, it's not really doing anything. But let me see, we could also do this and take the multimeter, which we were liking, and put it in there, and we can measure like some amps. So give me a second here. I'm going to move this around a little bit. Don't want to do that. Let's see. Let's move this over here. So those will hold on there. That's pretty cool. And I'm just going to go here, and I'm going to move this around a little bit. And let me see. I kind of need the positive connection going in here, and the negative connection going in here. And if you're using the multimeter for amperage, the thing has to be sort of made part of the circuit. So I'm going to go like this. I can make this be red if I want, and make this guy be black again. And let's see what happens. Let's just see. This is just to go to battery like outputs. So let's go for it. Ready, go. Okay, so it puts out like 6 amps of power. Okay, that's a lot actually. I think like 2 amps will kill you. I'm not sure. But 6 amps is like serious power. So this thing's like totally wasting itself on us. Okay, and let me stop that. Okay, so we learned something, which is cool. And I'm going to take our ammeter like we did the other day and kind of rotate it around. bring it back up here. Okay, and then what I'm going to do is I'm going to include it in our circuit so we can look at what happened. I'm going to, let me see, put this into here. These guys are kind of messy now, so I'm going to delete them. And so if I just click on them and hit delete button, it'll work. Let's go back up to here. Let's go back up to here. Let's make that black. Whoopee, black. And you can, if you want to, it's fine with me to use it like blue is sort of a, it's a darker color. Anything on the dark side is okay. Or a non-warm color, I guess is what I'd say. Maybe go for red. Go back to this, right? That seems to make sense. And it looks neat, and that's good because neatness is important. Okay, and then what we're going to do is I'm going to hook up an LED now to this. Okay, so this is my red side. And this is my darker side, so I'll make it like purple. And then I'm going to look for an LED. Okay. Do something better. What is it? Yeah, sorry, I just I don't know what I hit over here, but I just moved this back over. I just refreshed it. So let's get an LED. Okay, we like LEDs, and we notice that an LED has a positive side and a negative side, and you have to kind of respect that. Okay, and the anode side's the positive side. Okay, so this is my positive side going into my LED over here. Okay. And what we're going to do is just kind of get a connection back over to here. Okay, so this can be black. Okay, and then like as we ran this last class, we noticed that if you do this, it blows the thing up. Okay, and what it's telling you is that the absolute minimum and like milliamps is this. Okay. So, so that's sort of a problem, okay? So, what we want to do is we want to use a resistor. That's what we were learning about, okay? So we're going like this, and resistor resists current. And if I go like this and connect up here, and I run it right now, this is a really, really big resistor. It's got kiloohms of resistance right now, okay? And if I run this, what it'll do is it runs at very, very low amperage. Okay, so what's going on is it's giving you 7 milliamps of current, right? And that's kind of like too low for it. Okay, so what you can do is you can use the Ohm's law calculation or the equation to do a little math here. And get this to work. Okay, so let's look at that for a second. So the calculation is like Ohm's law, and Ohms was a person who used to study electricity and things like that. So this is like basically using the Ohm's law. Okay, and it works like this. Basically, the equation is V equals I times R. Okay, so for a appliance that's working well, okay, and like if we took out this resistor and we ran it, like what happens is the program actually tells us what we want. Okay, so what we really want is something that's going to work best with. We want to find a resistance for the current voltage that gives us as close as we can to what would be 20 milliamps. You can see it right there, okay? So 20 milliamps makes the, in this case, okay? So, okay, so 20 milliamps is best, and that's what's going on, okay? On the voltage side, we know that it has 9 volts, okay? We know I is the French word for amps, like the current, okay? So I'm going to turn this off because it hurts the light, right? I is the current. Okay, so that's 20 milliamps, but the equations worked in terms of volts, amperes, and that's milliamps. That's a problem. So we have a conversion problem, and like resistance. Okay, so milliamps are just basically like if you take 20, right, and divide by 1,000, because a milli is 1,000. That's what you get. Okay, so that's the number of amps that we're talking about. So if we go 0.02 amps, okay, times R, we'll get the resistance that we need in terms of ohms, okay? And there's a lot of like scientific, like there's units that we're using, but amps and volts cancel out to ohms, okay? So basically, if we just take 9 volts divided by 0.02 like amp, that's going to equal the correct resistance, okay? So if we do that, and we take 9 and divide by 0.02, we get 450 ohms, okay? Now that's sort of weird because actually most LEDs are happy with about 220, but we'll like do some experimenting about this, okay? So what we think is that R is going to equal, and this is why science is cool, is that we think that it's 450 ohms, and we'll put that in there, okay? So what we're going to need is a resistor that's about 450 ohms of resistance, okay? So let's do this. I'm going to go back over here. I'm going to open this up. I'm going to spread this out a little bit so we can see it better, okay? And I'll leave this over here. Okay, and what we're going to do is pull out a resistor, bonk, and put it in. And then couple it back up to our circuit, okay? We'll make this black, okay? And then if I go here, I'm going to change this to ohms, and then I'm going to write, and I want you to look at the colors of this, okay? Because there's actually a way to like actually check resistors to see what colors they have. There's a color code thing, okay? So what's going on is that I have a resistor that has a yellow band, a green band, and a brown band, okay? And the yellow means like 4, okay? And this one means 5, and this one means multiply 4 or 5 times 10, and that's going to be 450, okay? So that's what we've got, our 450 resistor. Let's run it now, okay? And what's going on is that we have 15 milliamps, okay? So we actually, like that sounds pretty good for this. You don't want to run it totally like at the 20 because that's a little bit high, but we could actually go down. So let's have less resistance and see if we can get more power out of it. See how you get 17.3? If I go down, let's try like 350. That's like almost at its peak, so that's probably not super good. So anyway, running it at 73 milliamps is good, okay, at a certain thing. Let's see how much, like exactly 20 would be. So we said 350, okay. Let me try 340 because I think I can do it. That's too much. See how it's giving me a warning right here? Okay, so let's try 345. Like that would be perfect, the resistance, right? So the resistance here at for one lamp is that, okay? So what I want to do is that's pretty like, let's go back to 350. It's probably better for the lamp, right? Even 360, do that. Okay, so that seems pretty good. And it's like glowing brightly and like things are good. Okay, so that seems fine. What we want to do though is for homework, what I want you to do is we do kind of one extra thing, okay? So let's find out if I add an extra light, okay? So what I can do is I can add an extra light like this, okay? And then what's going to happen is what I need to know is what's going to be a good resistor here. Okay, so I can put them, this is putting lights like what is called like in parallel. And I still need a resistor, I think, because 9 volts is pretty high. But I want you to kind of figure out what we need here, okay? So so that's sort of the assignment here right now, okay? And we'll look at this, and then there's other ways to kind of set up lights, and we'll look at that too, okay? But let's do that, and like I want you to tell me what the resistor I need for that. So what I want you to do is figure all this out, get this set up.